Hello, algebra students. Mr. Lawrence here with your flipped lesson. And after today, you're going to be able to say, I can factor trinomials by grouping. And this is actually the last type of factoring we're going to have to do. I know there's been a lot, and you've got to stay up on it. You guys have been working hard. Let's review very quickly. GCF, when do we, oh, pardon me, achoo. We always try the GCF first. Pardon me, my allergies are acting up on me today. All right, and then we know about grouping. When do we do grouping? Achoo. When there's four terms. We always use grouping when there's four terms. Now, today it's going to be a trinomial that we're going to do by grouping. We're actually going to turn it into a polynomial with four terms. So I hope that doesn't mess you up too much. Actually, it's really not that hard. Just a couple steps you have to do. Pardon me, my music's getting a little bit loud. Okay, and the difference of perfect squares. Remember, when do we use that? Achoo! When we have a binomial and there's a perfect square minus a perfect square. Man, the pollen count must be through the roof today. All right, trinomials with a lead coefficient of 1. There we go. It's a trinomial, and the lead term looks like x squared. Okay, and then we just learned about uh, the perfect square trinomial. And that one is the most difficult to explain, but it's actually easy to do. A trinomial when the first and third terms are perfect squares. The second term is twice the product of the square roots. Okay? If you can identify it, it's really easy to do. It's kind of wordy to explain. All right, but today we're going to learn how to factor other trinomials, and we're going to use the grouping method. So let's take a look at example number 1 here. Well, let me get some different color here. I have a trinomial. The lead coefficient is not 1. Okay, I'm going to rewrite this problem as a polynomial. I'm going to break this 13 up into two terms. Okay, but before I do that, I'm going to multiply the 2 times the 15. And 2 times 15 is, of course, 30. I'm going to list the factors of 30. 2 and 15, 3 and 5. And notice how I list them in order. Getting larger on the left-hand side, smaller on the right-hand side, and then I know when I'm done, because now the only number I have to check is 4, and I know 4 doesn't go into 30, so I've got all my factors. Okay. Hold on one second here. Sorry about that. I knew I had a mistake here, and I couldn't figure out what it was. 3 times 5 isn't 30. 3 times 10 is 30. 4 doesn't go in. 5 goes in 6 times. There we go. Now we're a little bit better. I can do this. Okay. Now you see this addition sign here? I'm going to add these two factors of 13 to get, two factors of 30 to get 13. Well, that would be like these two, right? 3 plus 10. And now I'm going to rewrite it as 2x squared. And I'm going to break this 13x up into a 3x and a 10x. So I'm going to put plus 3x here, and then plus 10x, and then plus the 15. So you see the 2x squared just came down, the 15 just came down, but I broke 13x up into 3x and 10x. Now, it's got four terms. I'm going to go ahead and group it. Now, you might be wondering, why did I choose to write the 3x first and the 10x second? Some of you are going to say, because it came first over here. No, because I knew I had a GCF in these two, and I knew I had a GCF in these two. If I could have switched them and had GCFs, which I could, then I could do it the other way. I could do 10x plus 3x, okay? I'm going to GCF this first group, pull out my x, right? GCF is x, sorry. And I'm going to get a 2x plus a 3. GCF over here is a 5. And I'm going to pull that 5 out. And then I'm going to be left with a 2x plus a 3. One more step will get me the quantity of 2x plus 3 times the quantity of x plus 5. And there we go. We just factored this red trinomial right here. If I FOIL this to check it, I will get 2x squared plus 13x plus 15. All right, let's try that again. Hold on, that last number there looks kind of weird. It's supposed to be a 4, I believe. So I'm going to change it to a 4. Okay. Looking for a GCF, I don't see one. Trinomial lead coefficient is not 1. I'm going to multiply 15 times 4 and get 60. So I'm going to list the factors of 60 over here. So 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. 7 doesn't go in, 8 doesn't go in, 9 doesn't go in. I'm done. Okay. Now, since there's a plus here, I'm going to add to get negative 23. Well, first of all, just get 23. 20 and 3, right? But to get negative 23, they both have to be negative. So here's how I'm going to write this. I'm going to write 15x squared. He just comes down, right? But I break the negative 23 up into two parts, a negative 20x and a negative 3x. And I'm going to go with a negative 20x here, and then minus a 3x there, plus a 4. Now I can do grouping. So I'm going to group the first two terms, going to group the second two terms, making sure to grab that negative. Doesn't look like it came in, I'll stick it in there. Okay, GCF between the first two terms looks like it's going to be a 5x. Pull out the 5x, I'll have a 3x left. Pull 5x out of there by division, I'll have a minus 4. Here, notice how I have just a negative 3x plus 4. There's no GCF, but I could pull out a negative 1. Negative 3x divided by negative 1 is 3x. 4 divided by negative 1 is minus 4, and look at that. The two quantities match. Didn't look like I had a GCF. Some of you were thinking I probably made a mistake, but actually, Mr. Lawrence saves the day. So now I'm going to divide this by 3x minus 4, and divide that by 3x minus 4. And I'll have a quantity of 3x minus 4 times a quantity of 5x minus the 1. And there you go. We just factored 15x squared minus 23x plus 4. All right, got a couple more examples here for you. Looking for a GCF on this trinomial. Don't see one. Going to multiply 12 times 15. Well, if I triple 15, I get 40. If I double that, I get 90. If I double that, I get 180. So I need the factors of 180. Okay, 2 and 90. 3 and 60. Yeah, 3 and 60 will work. 4 is going to work. 45. 5 definitely will work. Let me see here. How many times is 5 going to go in there? 36, I think. I should double check that, but I'm pretty sure. But let me just double check. Yep, that's good. 6 should go in 30 times. 7 I don't believe will go in. 8 isn't going to work. You know how I know? Because if I double 4, I get 8. I can't cut 45 in half evenly. 9 will definitely work. 9 and 20. 10 and 18 will work. 11 won't work. 12 just might work. Yeah, I think 12 is going to work. If I take a 4 out of there, that'd be 12. But then I have 15 left, right? 180 divided by 12. Oh, silly me, that's what I did in the beginning. I don't believe 13 or 14 are going to work. All right. Now you see this is a negative now? I'm not going to add these two factors. I'm going to subtract to get positive 8. In other words, the larger number is going to have to be positive. So how am I going to get positive 8? Ooh, look at these two right here. What if I did 18 minus 10? That would give me a positive 8, wouldn't it? So I'm going to put a negative here in front of that 10. And I'm going to rewrite this as 12x squared plus 18x minus 10x minus 15. All right, going to do a little grouping now. Need to group. Put my quantities in there. Got to look for the GCF. Looks like it's going to be a 6x and a 6x. And I will pull a 6x out. I'll be left with a 2x and then a 3. And there I have to pull a negative 5 out and a negative 5. And I'll have 2x plus a 3. And look at that, how they match up. So I'll get the quantity of 2x plus 3 times the quantity of 6x minus 5. And there you go. It factors. Hold on a second. I want to restart my music. Pardon me. Oh, I always forget to do that. Sorry about that. The airliner's in write mode, and so therefore I wrote instead of push the button. Okay, 3 more examples. I'll try to do them a little bit quicker. I don't see a GCF on this trinomial. I'm going to multiply here and get 90. List the factors of 90. 1 and 90, 2 and 45, 3 and 30. 4 is not going to go in. 5 will definitely go in. I'm thinking 18 times. 6 should go in. Yeah, if I 2 there, 6 and 15, 7 no, 8 no, 9 and 10, and I'm done. Okay, now it's positive 2, so I need to add to get 23, and it looks like 5 plus 18 is 23. So I'm going to rewrite this as 45. Oops. Rewrite it as 45x squared plus 5x plus 18x plus 2. Gonna do a little grouping. Always grab that sign, put a plus in between them. Looks like the GCF is going to be a 5x. GCF comes out. I divide to get 9x. 5x divided by 5x. Don't want to be pushing floor. Plus 1. All right, 2 and 2. 9x plus a 1. Look at that. I have a quantity of 9x plus a 1 that I'll factor out and a quantity of 5x plus 2. And man, I'm getting good at this. Okay, 2 more quick examples. All right, sorry about that. Wrong button. Okay. No GCF in this trinomial. I'm going to multiply 10 times 30 and get 10 times 3 and get 30. Notice I ignore the negative. I just keep it positive until it's time to get that middle coefficient. 2 and 15, 3 and 10, 4 doesn't go in, 5 and 6. So since that 3 is negative, I'm going to subtract to get 1. Well, it looks like 6 minus 5. So I'm going to write 10x squared, but you know 10 and 5 look like they go together better to me. So I'm going to rewrite it like this. And you know, minus 5x plus 6x, that's a positive 1x. So you see it matches, right? Okay, going to do my grouping thing now. Group these two, group these two. My GCF is going to be a 5x, 5x. Pull that 5x out. I'm going to have a 2x minus a 1. GCF over here looks like it's going to be a plain old 3. And I'm going to pull that 3 out. Get a 2x minus 1. I'll get the quantity of 2x minus 1 times the quantity of 5x plus 3. And there you go. All right. Last example, ladies and gentlemen. No GCF. Trinomial. Going to multiply 8 times 21, which I think is going to be 168. Going to go for the factors of 168. 2 and 84. 3 does go in. Wow, it surprised me. Okay, 3 is going to go in. Let's see, 168. It's going to go in as 16 5 times. 56. Yeah, that's right. Okay, 4 should go in. 42 times. 5 will not go in. 6 should go in. If I cut that 56 in half, I'm going to get 28. I don't think 7 will go in. Let me check that one. I don't know a lot of cool tricks for 7s. 168 divided by 7. Ooh, it does go in. Fooled me. 24. 8 will go in 21 times. That's what I multiplied to get it. 9 will not go in. 10 will not go in. 11 shouldn't go in. 12, yeah, I think 12 should go in here. Let's see here. If I take a 2, get 28, I think in 12 and 14. Let me just double check that. Yep, sure is. And 13 times 13 is 169, so it won't go in. All right, now you see how this is negative? I need to subtract to get negative 53. It's going to be a subtraction problem, and the one that is larger, the factor that is larger will have the negative sign. Well, look at the 56 and the 3. Just make the 56 negative and the 3 positive, and I've got what I wanted. All right, I'm going to rewrite this as 21x squared. I'm going to group the positive 3x with the 21 because I see a GCF. And then I have a negative 56x minus 8, and I see a GCF there. So I'm feeling pretty good about this problem. Time for my actual grouping. Grab that sign. GCF looks like it's going to be a 3x. Pull that 3x out, and I'm going to get 7x plus 1. And then I'm going to pull out the negative 8 here. They're both negative, so I'm pulling out a negative. You guys know that. And that'll be 7x plus a 1. And look at that. 7x plus 1 times the quantity of 3x minus 8. And I am done. All right, that is the last type of factoring we need to learn and become good at, master. Mr. Lawrence signing off. Good night, everybody.